Hi everyone, we are doing our 9.2 notes today, which is our special right triangles. We're going to learn about two special right triangles today. I'm going to skip the vocab because we know what an isosceles triangle is. Here's our first theorem. It's about a 45, 45, 90 triangle. One thing about these is that a 45-45 triangle, since two angles are the same, that means we have an isosceles triangle. So what we have here is we have an equation that says our hypotenuse is, the distance of our hypotenuse is equal to the distance of our leg times the square root of 2. And we also have a picture here. Another way I'm going to write this picture, I'm going to draw a little right triangle here just because it might be helpful for some of you later. Is if we know where our 45-degree angles are, instead of writing x's, we can write 1s for the legs and square root of 2 for our hypotenuse. And we can use similar triangles and set up proportions to solve these problems that we're going to see today. Or we can just use an equation. No matter what, you have to memorize either a picture to do proportions or memorize three formulas. When I say three, that's because we also have the 30, 60, 90 triangle theorem. And this says in a 30, 60, 90 triangle, the hypotenuse is twice as long as the shorter leg, and the longer leg is square root of 3 times longer than the shorter leg. So I'm going to quickly redraw a 30, 60, 90 triangle. So here's my 90, here's my 60, and here's my 30. What I'm going to say is find your 30 and go directly across. And this is your shorter leg, and we're going to write that as a 1. And then find across from your 90, that is your hypotenuse, and that is worth a 2. And then the other side is going to be your longer leg, which is worth the square root of 3. And then we have our two equations at the bottom of this image, which says the hypotenuse is the shorter leg times 2, or the longer leg is equal to the shorter leg times 3. So I'm going to model using equations and proportions to do some of these questions. So let's go to the next page. All right, so let me make it a little easier to see these. I'm going to move it up just a smidge. Here we go. Number one, this is a 45, 45, 90 triangle. So if we're going to do the equation, I'm just going to shortcut this. I know the equation for 45, 45, 90 triangle says our hypotenuse is equal to the leg times the square root of 2. And so this is my leg, this is my hypotenuse, so I can just fill in what I know. I know my hypotenuse is x, my leg is 10, I'm going to keep that square root of 2. So to solve for x, it is just 10 square roots of 2. All right, wonderful. Look at number 2 here. And number 2, I'm going to do the same thing. I'm going to find my hypotenuse. Now, how do I know this is a 45, 45, 90 triangle? Notice that my two legs are congruent. And because they're congruent, that means we have an isosceles right triangle, which means we have a 45, 45, 90 triangle. So let's go ahead and write down our formula here. Our formula says our hypotenuse is equal to the leg times the square root of 2. So our hypotenuse here is x. Our leg is square root 2 over 2. And I'm going to keep this times square root of 2. And it just so happens the square root of 2 times square root of 2 is just 2. I keep the denominator, which is 2. When I solve, I get x equals 1. Okay, so how do I want to do this if it's a proportion? If you want to set up as a proportion, here's what I recommend, is you write the numbers. We know with the numbers that our legs are worth 1 and our hypotenuse is worth square root 2. That's what I have here written in red. So what I can do is I can look for my x. So my x is on top. X compares to 1 equals, another value from the original triangle is 8 square root 2, and that corresponds with, in my similar triangle, a square root of 2. So notice if I write in my 1 square root of 2 from the triangle that I drew on the first page of these notes, if I put these in, x and 1 are corresponding, square root of 2 and 8 square roots of 2 are corresponding. I have to solve this now. Just so happens these square roots of 2 cancel, and I get x equals 8. Again, I'm going to do another proportion on this one. It's a 45, 45, 90 triangle. So my hypotenuse is always the square root 2. The legs are the 1s. So I'm going to look at, I'll actually highlight it this time. I'm going to look at the x. The x corresponds with 1 equals, and now I can look at my 12 corresponds with the square root of 2. So I'm going to put 12 over square root 2, and now I get to solve this. It just so happens to solve this, I have to rationalize the denominator. So I'm going to multiply both sides by the square root of 2. That gives me 12 square roots of 2 over 2, which means I get x equals 6 square root 2, because 12 divided by 2 is 6. So again, you can solve it using the equations, or you can use the proportion method. Now let's look at our 30, 60, 90 triangles. Again, I'm going to do some with equations, some with proportions. So if I do the equations, what I would do is I'm going to first separate this into like 3 separate problems here. I'm going to set up my 2 equations. I know that my hypotenuse is equal to my smaller leg times 2, and then my larger leg is equal to my smaller leg times the square root of 3. Only thing you don't want to do is have 2 variables in the same equation. So if I look at my triangle, I'm going to go across from 30, that is my small side, across from 90 is my hypotenuse, and my longer leg is what's left over. So let's look at my first equation here. Hypotenuse equals the smaller leg times 2. My hypotenuse here is my y. My smaller leg is the 15. I'm going to keep the times 2, so y is simply just 30. Let's look at the longer leg. The longer leg is x. My smaller side is 15. Keep that square root of 3. It just so happens 15 times square root of 3 is 15 square root 3. Let's look at number 6. Again, I'm going to set up my 2 equations. I'm going to say hypotenuse equals the smaller leg times 2, and my longer leg equals my smaller leg times square root of 3. I'm going to find my 30, 60, 90 angles here. So my 30 is the one I don't know. So across from that is my small leg. Across from my 90 is my hypotenuse, and then I have my longer leg. Now notice I have a variable as my small leg, so both of these are going to have a variable. But I also have my longer leg as a variable. So I cannot use my second equation here that I'm circling really slowly with my red arrow, because I will have an x for my L and a y for my S, and I cannot have 2 variables in the same equation. So I'm going to focus on my first equation. My hypotenuse in this this diagram is 22. My small side is my y that I don't know, and I still have my times 2. So when I divide both sides by 2, I get y equals 11. Here's my trick for you. Go back to your diagram, cross off that y, and physically write in the number 11. Now we can go forward with the second equation to find the longer leg. My longer leg in this problem is now my variable x. My smaller leg is the 11. I keep that square root of 3, and it just stays x equals 11 square roots of 3. Number 7, I'm going to show you this one with a proportion. So I'm going to draw, facing the same direction, my triangle. Here's my 30 and my 60. And if you go back, I'm just drawing this so you can see where my numbers are coming from. From the front page, across from my 30 was my 1. Across from my hypotenuse is my 2. Then I have my square root 3. So if I know that, I could go into my regular triangle and say across from 30 is my 1. Across from my hypotenuse is my 2. And then I have my square root 3. Let's set up a proportion. If I want to find x, x compares to 1. It corresponds with 1. Now I want to find a leg or a hypotenuse, whatever has 2 numbers. So I see 9 and square root 3 over here. So I'm going to say equals, and then I can say that 9 compares to the square root of 3. Well, now I need to solve that proportion. So dividing by 1 doesn't really matter. What matters is I have to rationalize this denominator. So I'm going to multiply both sides by the square root of 3 to get 9 square roots of 3 over 3. So x is just 3 square roots of 3. Let's look at our last proportion that we need for this specific one. I'm going to find y. Y compares to 2. And then I'm also going to say that my 9 compares to my square root 3. So I'm going to multiply both sides by 2. So I'm going to get y equals 18 divided by the square root of 3. But then I have to rationalize that by multiplying both sides by the square root of 3. And when I'm done, I'm going to zoom out just a little bit. when I'm done, I'm going to have y equals 18 square roots of 3 over 3, which is 6 square roots of 3. So there's my y value, and we have our x value. All right, a couple of the other problems going forward. Next page. All right, in these exercises, we should sketch a figure and then find the indicated measure round to the nearest tenth. So it says the length of a diagonal of a square is 32 inches. Find the perimeter of the square. So here is my square. The length of the diagonal is 32 inches. And if we have a square, we know these two are the same, which means if I'm going to highlight this, I have a isosceles right triangle because we also know that each angle is worth 90 degrees. So I have my leg and I have my hypotenuse. So if you remember, I want to find my leg because perimeter is all four sides of the square added together. So my hypotenuse equals my leg times square root of 2. Well, my hypotenuse here is 32. And the next thing you know, I'm going to set that equal to my leg, which I don't know, times square root of 2. So if I divide both sides by square root of 2, I'm going to get that my leg is 16 square roots of 2. Just bear with me here. That's one leg. There are four legs. 1, 2, 3, 4 in a square. So I can take 4 times 16 square roots of 2, but it did say round to the nearest tenth. Putting that in the calculator, that is roughly 90.5, and we're talking about inches. Now, an isosceles triangle with a 30-degree base. So isosceles triangle. So this is 30. This is 30. That's a total of 60, which means this whole angle up here is 120. Has an altitude. Remember, altitude is where you take from the top and you're going to go straight down to make it perpendicular. Now, it just so happens that if we had those 30s and these are 90s, these angles here are both 60. And this altitude is worth the square root of 3. So I'm going to redraw the triangle that I really have here. I'm going to redraw. I have a right triangle that has my 30, my 60, my square root of 3, and what we're looking for is find the length of the base. So I need this, but notice there's 2 of them for my whole base on the big triangle. I'm going to use my proportion method here. My proportion method says go across from 30, okay? Go across from 30, and that's going to be my side that's worth 1. Across from my hypotenuse is 2, and then I have my square root of 3. Now notice I only know 2 of my 3 sides here, and that's okay. To solve this, I'm going to say x compares to the square root of 3, and the square root of 3 compares to 1. To solve this one-step equation, I'm going to multiply both sides by the square root of 3. So these cancel, and I'm going to get x equals 3. So if x equals 3, I'm going to go back to my original equation here. And if I put 3 here, and I know the other side is also 3, 3 plus 3 means the length of the base of the entire isosceles triangle is going to be 6 meters. That is the whole base, the 3 plus the other 3. We have 6 meters. Last question, find the area of triangle DEF, round decimal answers to the nearest tenth. So I'm going to first zoom in to this first triangle here to show you that we have a 30, 60, 90 triangle. So if we think about what's going on here, we have our side lengths. So we have 1, 2, square root of 3. What I don't know is this x here. So again, I'm doing a proportion method here just to model that. So if I do my proportion method, I'm going to say x over 1 equals 7 square roots of 3 over the square root of 3. Well, to solve this, my square roots of 3 cancel, and I get x equals 7. So what can I do? I can go over here and say this is worth 7. Now, I still need to figure out the other side of this triangle. So let's focus on, make this like a y. Y over 2 is now the same as 7, sorry, y is my, 7 square roots of 3 over the square root of 3. Cross this off, y is worth 14 when I solve. So this side is worth 14. All right, so I'm doing all that work so I can basically redraw the big triangle without anything else in it. So let's see what I know about this big triangle. I know it's not really drawn to scale here. What I know is this side's 28. And that's about it. Now notice what I have here. If that's 28, let's focus on just the little triangle here. Look at that little triangle. Notice this side right here. That's 14. This is 28, which means if I go from one to the other, this has a scale factor of times 2. So if this bottom side is 7 times 2 means this side's going to be 14. And then if I take this 7 square roots of 3 and multiply that by 2, it gets me 14 square roots of 3. And I need to know that because to get area, I need half my base times my height, which is 1/2. My base here, I can look at as my 14 square roots of 3, and my height would be 14. And now I'm going to put this in the calculator, but it says to round to the nearest tenth, which is going to be 169.7 meters squared. All right, there are the notes. Any questions, reach out. Now, we'll see you in the next video or in class. Have a great day.